Hi, this is Ms. Cho on complex numbers and powers of I. Complex numbers are the largest group that contain real numbers, imaginary numbers, and combinations of the two. Complex numbers can be written in the form a plus bi, where a is the real part and b is the imaginary part. Purely real numbers have the form a plus 0i, so that the imaginary part goes away. And purely imaginary numbers have the form 0 plus bi, so that there's no real part. Complex numbers can have one or both parts. For example, when you solve quadratic, sometimes you get something of the form -1 plus or minus 3i root 2. That's a complex number. Or you can have, 4 plus or minus 2i. We're going to focus on the base unit I and what happens when you raise I to different powers. What exactly is I? We define I to be the number that when you square it, you get -1. So in other words, we use I to mean the square root of -1. What happens when we raise it to different powers? The first power I'm going to talk about is I to the 0. Anything to the 0 power, whether it's 2 to the 0, 17 to the 0, -8 to the 0, is always 1. And then I to the first power, anything to the first power is always itself. I squared by definition is -1. I cubed is just I squared times I, and I squared is -1. So it's -1 times I, which gives us -I. What about I to the fourth? I to the fourth is just I cubed times I, and that's -I times I, which gives us -I squared, which is negative of -1 or positive 1. But then it looks like that I'm already back at where I started with positive 1. So I fourth is the same as I to the 0. Which means if I keep multiplying by I, I'm just going to go around the circle like a clock. So I fifth is going to be like I1, I sixth is going to be like I squared, I seventh, I eighth, I ninth, I 10th, I to the 11th, I to the 12th. You get the idea. I'm starting to notice a pattern here. I noticed that at the top, all of these numbers, 0, 4, 12, these are all multiples of 4. And they have a remainder of 0. 1, 5, and 9 are all multiples of 4 plus 1, so they have a remainder of 1. 2, 6, and 10 are all multiples of 4 with remainders of 2. And 3, 7, and 11 are multiples of 4 with remainders of 3. So it looks like the remainders will tell me what position of the clock that I'm on. And I can keep going around and around and around, but my remainder will tell me where to stop. Think of this like military time. You have 13 o'clock, you start at 12 and you go all the way around to 12, and then 13 would just be one more. So 13 o'clock is the same as 1 p.m. If we know that this clock goes in a pattern like this, we can find any power of I, even when they're really big. Let's take a look at an example. In this example, we're asked to simplify I to the 15th power. So I'm going to draw my clock to help us out. If I really wanted to, I could just count my way around. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 tells me that I am at -I, but this is kind of time consuming and not super efficient. So let's take a look at how we can do this algebraically. The first thing we want to do is rewrite our exponent into two parts. Recall that when you multiply numbers of the same base, you add their exponents. So x to the fifth can be rewritten as x cubed times x squared, or x to the fourth times x to the first. We want to rewrite I to the 15th as I to some power times I to some other power. And we want to choose our power strategically. We want the first one to be a multiple of 4, and we want our second one to be the remainder. The largest multiple of 4 less than 15 is 12, and then our remainder is 3. In step 2, we're going to use our clock to help us. I know that any multiple of 4 is going to be at the 0 position. So I to the 12th, because 12 is a multiple of 4, is going to be equal to 1. And then I cubed is -I. Step 3, I just multiply what I found in step 2. So 1 times negative I is negative I, which is exactly what we found when we counted our way around. In this example, we're asked to simplify I to the 142nd. I'm going to draw my clock for reference again, but I definitely don't want to count my way around. First, we rewrite 142. Remember, the second one is going to be my remainder, so I want to know what my remainder is when I divide 142 by 4. And then my remainder is 2. So since my remainder is 2, means I added 140 to 2 to get 142. My step 2, I use the clock. 140 is a multiple of 4, and any multiple of 4 will end in the 0 position, or be 1. And then the 2 that I squared is negative 1. So then my step 3 is the multiply. And I find that 1 times negative 1 is negative 1, which is my final answer. To summarize, complex numbers can be written in the form a plus bi. We define I to be the square root of negative 1. And we find that when we raise I to different powers, it cycles among 4 different numbers. To simplify powers of I, first you break your I exponent into 2 parts. The first part will be the largest multiple of 4 before that number, and the second part is the remainder when you divide that number by 4. In your second step, you use the clock to see what each part equals, and in your third step, you multiply your results from step 2 for your final answer.